In this video, we're going to talk about integration by parts. Let's see the definition first. The integration rule that corresponds to the product rule for differentiation is called the rule for integration by parts. This is the formula for integration by parts. Integral fx g prime x dx equal fx gx minus integral gx f prime x dx. We can also let u equal fx and v equal gx, then du equal f prime x dx, and dv equal g prime x dx. Then we get the second formula. Integral u dv equal uv minus integral v du. Actually, the second formula is the same as the first one, but we often use the second one because it's a lot more easier for us to remember. For better understanding this formula, let's see where the formula comes from. So based on the product rule, we can get the first equation, d dx of fx gx equal fx g prime x plus gx f prime x. Then we take integral for both sides, and we'll see for the left side, it will be the integral of derivative of the product of fx and gx. So here we will get the original fx gx on the left, and on the right we'll integrate the whole part of the right side, and record the integral of a plus b is equal to the integral of a plus integral of b. So we get the integral of two parts respectively. Finally, we get our formula, which is fx gx minus integral gx f prime x dx equal integral fx g prime x dx. Here we also can let u equal fx, then du equal f prime x dx, and dv equal g prime x dx, and v equal gx. So we get our second formula, integral u dv equal uv minus integral v du. Students often get confused with U-substitute and partial integral. Let's recall U-substitution. It's a way to reverse the chain rule. Let's look at the example here. The integral x e to the power of x squared dx. Here we can let u equal x squared, then du equal 2x dx. Then we can substitute x and x dx, and we get the integral of eu and 1/2 du. So finally, we can use the u substitution to solve this problem. Now let's see another example. Integral x e to the power x dx. We cannot use u substitution to solve this kind of problem, because it's not a u substitution with one function inside the other. Actually, it's the product of two functions. So we need to use the integral of parts. The formula here, integral u dv equal uv minus integral v du to solve this kind of problem. Now we know the formula, but you may ask, how do we know what to choose for u and dv? With u substitution, you looked for one function inside another. For integral by parts, we use the LIATE rule. What is LIATE rule? Let u in this order, L, I, A, T, E. So L stands for log, I stands for inverse trig, A stands for algebraic, T stands for trig, and E stands for exponent. Let's see an example. Integral ex cosine x dx. How we choose U? So here is the product of an exponential and a trig function. By the rule, the trig is before the exponent, so we will let U be the trig. So here we will let U equal to cosine x. And then we have the left part xdx, and let dv equal to xdx. Then we have du equal negative sine x dx, and v equal ex. Use our formula. Integral u dv equal uv minus integral v du. We'll have cosine x ex plus integral ex sine x dx. Let's do some practice. Integral x sine x dx. First, we need to choose which part we let u be. According to the LIATE Rule, we know x is the algebraic and sine x is the trig. So a is in front of the t. We will choose u in the order of LIATE Rule. So we will let u equal to x, and then dv equal to sine x dx. And then we get dv equal to sine x dx, and v equal to negative cosine x. Use our formula. Integral u dv equal uv minus integral v du. We'll get x times negative cosine x minus integral negative cosine x dx, and equal to negative x cosine x plus sine x plus c. Here we need to add plus c. It's very important. It stands for the constant. Let's see another question. Integral x natural log x dx. Same here, according to the LIATE Rule, we need to decide which part we let u be. We can see here x is algebraic and the natural log is log. So here natural log x is in front of the algebraic. So here we let u be natural log x and dv be the x dx. Then we will get du equal to 1 over x dx and v equal to x squared over 2. Again, we use our formula integral u dv equal uv minus integral v du. We will get natural log x times x squared over 2 minus integral x squared over 2 times 1 over x dx equal x squared over 2 natural log x minus integral 1 over x dx equal x squared over 2 natural log x minus x squared over 4 plus c. C is the constant. Let's see another example. Integral y e to the power of 0.2 y dy. Again, according to our LIATE Rule, y is algebraic, and e to the power of 0.2 y is the exponent. So here we will choose u be the y, and the rest part of is the dx. So du equal to dy, and v equal to 5e to the power of 0.2y. Again, here we use our formula. I here always recommend you to write down the formula in front of your answer. And we get our answer equal to y times 5e to the power of 0.2y minus 5 over 0.2e to the power of 0.2y plus c. And we can arrange the answer to 5ye to the power of 0.2y minus 25e to the power of 0.2y plus c. Let's see another example. integral x times 5x dx. Again, according to the LIATE rule, x is algebraic and 5x is exponent. So here we will let u be the x and dv be 5x dx. Then we get du equal to dx and v equal to 5x over natural log x. Here we need to recall the derivative of ax equal to ax natural log a. We use our formula here, and then we get x times 5x over natural log x minus integral 5x over natural log 5 dx. And finally, we'll get our answer, that is x times 5x over natural log x minus 5x over natural log 5 squared plus c. Let's see another example. Integral natural log x dx. According to the LIATE rule, natural log x is always the priority of we set u be. So here we let u equal to natural log x, and very straightforward, the dv is the dx. Then we get du equal to 1 over x dx, v equal to x. Use our formula again, we will get integral natural log x dx is equal to x natural log x minus x plus c. Let's see our last example, integral ex cosine x dx. This is a little bit challenging question, so pause the video to see whether you can find the solution yourself. According to the LIATE, ex exponent cosine x is trig, so we set u equal to cosine x, dv equal to ex dx. Then we get du equal to minus sin x dx, v equal to ex. Use our formula, we'll get integral ex cosine x dx equal to cosine x ex minus integral ex times negative sin x dx, which is equal to ex cosine x plus integral ex sin x dx. Here we get an integral. So how we do this? Okay, it's easy. Let's u equal to sin x here, and dv equal to ex dx. Let's see what's going to happen. Du equal to cosine x dx, and then v equal to ex. So we finally get integral ex sin x dx equal to ex sin x minus integral ex cosine x dx. Hey, we get another integral. But hold on. If we substitute the integral ex sin x dx with the right part, and we will get integral ex cosine x dx equal to ex cosine x plus ex sin x minus integral ex cosine x dx. We have integral ex cosine x dx both sides, and we can move the right part to the left part. So we get 2 integral ex cosine x dx equal ex cosine x plus ex sin x. Then we have our final answer, integral ex cosine x dx equal to ex over 2 times cosine x plus sin x. This is our solution. Thanks for watching. Hope this video helpful.